fractional indices and surds. Just a quick reminder that a surd, or surds, are numbers with root signs sorry, I'm writing too fast. Root signs, so that's this one, that are irrational numbers. That is, they can't be represented as a fraction. Their decimal parts will keep on going infinitely. So it's an infinite non-recurring decimal when you evaluate it. So while the square root of 4 is 2, that's not a surd. This is written in root form, but it's not a surd. The square root of 2, when you evaluate it, remember using the double arrow, 1.414, etc., just keeps going. So generally with the calculators you can assume that if any root value comes out to a bunch of decimals that fills your screen, you can assume that it's a surd, it's irrational. Now, fractional indices are powers where we have a fraction as the index, the exponent. And I'm going to start investigating these by looking at, I'm just going to pick 8 to the half, and what happens if we multiply that by itself. 8 to the half times 8 to the half. Because this is a good way of investigating what a fractional index equates to. Index law 1 says if we're multiplying indices with the same base, we add the powers, and a half plus a half is 1 whole. So this is 8 to the 1, which is 8. Our knowledge of square roots says that the square root of a number is the number that multiplies by itself to give 8. That is, the square root of 8 times the square root of 8 would have to give me 8. It's the definition of the square root of 8. It's the number that squares to give 8. So, since 8 to the half squared gives me 8, and the square root of 8 squared gives me 8, the conclusion is that 8 to the half is equal to the square root of 8. And that is our fractional index rule, that a number, in this case we'll call it a, to the power of 1 over m is equal to the mth root of a. Now that's because we can have other roots. Let's look at the cube root of 8, which I'm sure you can predict is going to be 8 to the third times 8 to the third times 8 to the third would give me 1/3 plus 1/3 plus 1/3, 8 to the 3/3, which is 8 to the 1, which is 8. 8 to the third is the cube root of 8. It is the number that cubes to give 8. So 8 to the 1/3 is the cube root of 8, and incidentally, we can double check with our calculator. The cube root of 8 is of course 2, because 2 times 2 times 2 is 8. So here is our rule. A fractional index with a 1 as the numerator, the denominator gives us that root of the base number. So we'll have a look at a couple of examples. We don't really go into what happens when we've got it's a non-unitary fraction, that is, it's a number other than 1 in the denominator, but I've got a couple of examples at the end. It's more year 10 work. So if I ask you to write a fractional index using a root sign, 6 to the power of 1/2 is simply the square root of 6. You can put a little 2 there, but any root sign without that 2 is assumed to be the square root. So I'm just going to check my focus here. Hope it's all right. 2 to the power of 1/5 is the 5th root of 2. That is what can be raised to the power of 5 to give 2. So that's how you change a fractional index to root form or a surd. You can change a surd back into a fractional index. The square root of 7 would be 7 to the power of 1/2. The cube root of 9 would be 9 to the power of 1/3. Now, because we can shift quite easily between fractional indices and surd form, we can choose the form that is most helpful to us for evaluating. So 144 to the power of 1/2 looks a bit baffling, but if we write that as the square root of 144, we're suddenly very aware that that's 12, because 12 times 12 is 144. 27 to the power of 1/3, if you write that as the cube root of 27, you should know that the cube root of 27 is 3, because 3 times 3 is 9 and 9 times 3 is 27. This is one of those relationships that you really should just recognize. Now, some harder concepts, so if you want to do some classwork first and then get to these when you need them, you may. Use index laws to simplify. Y squared to the power of 1/4. Power of a power rule says that we multiply our powers, so this will be y to the power of 2 times 1/4, and 2 times 1/4, you can either do 2 times 1 to get 2 over 4 and simplify to 1/2, or 2 lots of 1/4 is 1/2, whatever works better for you. So that's y to the 1/2 or the square root of y. Because they said use index laws to simplify, they didn't give us any other information, so you leave it in index form without any other context, because you started in index form and you used index laws. If they asked you to leave it, to change to surd form, you would, or if there was a reason why getting a surd answer would be easier for you, but just for simplifying, you remember I said usually leave it in the form it was in, index laws, index form. X to the 1/2 divided by x to the 1/3, use index law 2, which says that that is going to be x to the 1/2 minus 1/3. You will need to do some subtraction of fractions there. Obviously, this will put us over 6. So that's 3/6 minus 2/6, so we'll be left with x to the 1/6. Asking us to evaluate a negative fractional index, it is almost always going to be easier when you have a negative power to change it to a positive power by taking the positive reciprocal. Now I have 1 over 16 to the 1/2. Because they've said evaluate, that means I want the number answer or the fraction answer, obviously. And that means that surd form is going to support me best. 1 over the square root of 16, 1 over 4. We didn't need our calculator at all to evaluate this slightly scary looking power to something very meaningful. Now I've got here 8 to the 2 over 3, 8 to the power of 2/3, rather badly written. And this is where you see we've got our non-unitary numerator. Honestly, this is a bit extension-y, but there's a question later on, so we'll get to this. I find it most easy to separate out this power into, so I've got 8 to the power of 2 over 3, I'll write really large, into the numerator times the unitary fraction. That is, this is 8 to the power of 2 times 1/3. Now, because I've separated that out to a product of powers, you know, or you should remember, that when we multiply powers, it's because it was a power of a power. So I can rewrite this with brackets as either 8 squared to the power of 1/3 or 8 to the 1/3 squared. Having done that, it's going to help us to realise how we can get this into surd form, because anything to the power of 1/3 is that object's, or that number's, cube root. So this bit says the cube root of whatever's in the brackets, which is 8 squared. And that's the cube root of 64. At that point, if you want to check your cube root, 3, the xth root, 64, and we've got 4. If you'd been kind of a little bit feeling warm and fuzzy about cubing and squaring and recognizing things, you could have worked out 4 times 4 times 4 gives you 64. So we shouldn't need the calculator at that point, but if it's one of your less recognizable for us cubes, I'd understand that. Now we could have put it that way. So this is 8 to the power of 1/3 squared, and that would just let us know that the cube root of 8 squared is the same as the cube root of 8 squared, because that's what we got to here. So it doesn't actually matter if our squared is belonging to the term under the root or outside there to the power. So that's quite a useful little equivalency there. So what that shows us is that when I've got a number to the power of a fraction, which was a to the power of a fraction with a base of m and the numerator of n, what we will get is still the cube root here, so the mth root of a to the power n. Or, given this bit of information, we could get the cube root of a to the n. All sorts of things could be happening. We'll go into this much more in Year 10, but if you need it for some challenge questions, it's there.